All right, let's look at the homework 6.4, problem number 10. All right, let's evaluate this improper integral. All right, so first I'm going to use a substitution to make it look simpler. So I'm going to let u be x minus 2. All right. So going through the usual drills, take the derivative of u with respect to x. That's going to be just 1. And you can just multiply through, or you can just, let's do it as usual. Take the reciprocal of both sides. We get the dx over du is equal to 1. And then we can just multiply through by du. Right? So we know that dx is actually exactly the same thing as du. Alright, so since this is a definite integral, we have to do the limit conversion. So you have, so original x goes from 0 to 3. And you just need to convert it to u. Alright, so if you plug in u for 0, 0 minus 2, so u is going to start from negative 2, and then x is 3, so negative 2 to 1, right? So this integral can be rewritten as integral from negative 2 to 1, then you have a 1 over, right, u to the 4/3. Actually, I don't like fractions, so I'm going to actually rewrite it as u to the negative 4/3 du. Right? And as you can see that 0 is between negative 2 and 1, but when u becomes 0, because of the negative power, 0 is going to be on the denominator, so which would be undefined. So the bat number would be u equals 0. So I'm going to split this integral into two parts. Right, so negative 2 is okay, but when you hit 0, it's bad. So I'm going to use that as one of the limit, upper limit in this case. So negative 4 over 3 du plus we are going from 0 to positive 1. U to the negative 4/3 du. Right? So we have two integrals to deal with. So I'm going to call this one I1, integral 1, and call this one integral 2. Right? You can work on either one. Let's see. I kind of like the second one better, so let's work on I2. Right? So I2. Right? So the troublemaker would be, 0, because 0 will make the denominator 0. So I'm going to replace the lower limit by, say, a, and to 1. Then we're going to take the limit as a approaches 0 from the positive side, right? Then we still have u to the negative 4/3 du, right? So let's evaluate that. So you have a limit as a approaches 0 from the positive side. All right, antiderivative of this would be add 1 to the power, so you have a u to the negative 1/3. Divide by negative 1/3 would be multiplied by negative 3. And then you're going from a to 1, right? And since you have a number, negative 3 is just a number. So I'm going to just send it right in front of the limit. All right, so this is going to be negative 3 times limit as a approaches 0 from the positive side. All right, plugging 1, that's going to be 1 minus plugging a. So you have a to the negative 1/3 power. I'm going to actually write it as so negative, so it's going to be on the bottom. All right, 1/3 power is equivalent to a cube root, so this is going to be a cube root of a. So if you're plugging a, u to the negative 1/3 is same thing as 1 over cube root of a. All right, so we have that. All right, as you can see that as a approaches 0, right, 1 over 0, so this guy, maybe I'll use a different color. All right, this one approaches positive infinity, right? So you have a 1 minus infinity is negative infinity, times negative 3 would be a positive infinity. So this is going to go to positive infinity. But we know that this is divergent, right? So we have, this is a combination of two integrals and two improper integrals, and we looked at the I2, the second one, and the second one already is divergent, which means that the whole integral is going to be divergent. If one of them diverges, the whole thing is going to diverge. All right, so I'm going to answer this question. Integral diverges, and the answer is diverges. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.